Hello students, today we are going to talk about river and boat problems, specifically motorboat. Suppose that for a long time you had this desire to buy yourself a motorboat. One day you come into some money. So you go straight to the motorboat seller and pick a motorboat and say, I want to buy this one. What does it cost? And he says it costs 30,000 rupees and it will go at 6 meters per second. You're very happy, you buy the motorboat, give him the money and you take it to a lake. Lake, of course, contains still water. Put the motorboat on the lake and you start the engine and nothing happens. Try it again, nothing happens. So you bring the motorboat back to the seller, wondering if you've been cheated. And you say, my good man, you took 30,000 of my money and you said the motorboat moves at 6 meters per second. It doesn't move. And the guy says, if you take it to a river which is moving at 6 meters per second and put it on the river, it'll move at 6 meters per second. Shh. Now you're angry, aren't you? But that guy is a good man actually. He starts laughing and he says, sorry, I just made a bad joke. But listen, I got this good motorboat which can move at 12 meters per second on a lake. And in any direction you point it, it'll go at 12 meters per second. So this time you take the boat and you take it to the lake and sure enough, no matter which direction you point it in, it goes in that direction at 12 meters per second, working beautifully. So the moral of the story is, if you want to know the capacity of a boat, you have to find out its velocity in still water. So now you take this motorboat and take it to a river which is flowing at 6 meters per second. And now I have two questions for you. Question number one. If you point the motorboat straight across at a point directly across on the other bank and keep it pointed in that direction and run the motorboat, in which direction will it actually end up going and where does it land? That was question number one. The second question is, supposing you want to get to the point directly across the river on the other bank, in which direction should I keep the boat pointed so that the boat ends up going straight across? These are two examples of the kind of questions that you will face in NEET and JEE. River and boat problems are part of the relative velocity chapter. Let me quickly remind you that relative velocity problems usually concern two frames of reference. For example, one frame is the ground frame. In the ground frame, the ground, the trees, the buildings, they are all at rest. And in this frame, the velocity of the river is 6 meters per second. Now, any velocity measurements that we make in this ground frame, we will represent the velocity with the vector v. For example, I might look at the motorboat running in the river and the velocity of the motorboat as seen from the ground frame is v. The second frame of reference is the moving frame of reference, moving with respect to the ground. For example, the river frame of reference. How do I get into the river frame of reference? Not into the river frame of reference. I can either run alongside the river at 6 meters per second, in which case from my point of view the river will appear stationary, or I can get onto a raft and float along with the river. Again, I am moving with the river. From my point of view, the river is stationary. It looks like a lake. And in this frame of reference, the opposing bank and the trees, they all appear to be moving in the opposite direction at 6 meters per second. Now in this frame of reference, the velocity of the motorboat, we'll call it v prime. And u is the velocity of the river itself. That is the velocity of the moving frame of reference as measured in the stationary frame of reference. And the equation we have is v is equal to v prime plus u. In other words, in the frame of reference of the river, that is you're moving with the river, you find the velocity v prime of the boat, add to it vectorially the velocity of the river, you will get the velocity of the boat as seen from the ground. Now I've explained this equation in a little detail in another video. That video is called What is the Velocity of a Bird as Seen from a Moving Train? But let me quickly summarize. The equation is v is equal to v prime plus u. So now how do we apply this to solve our problems? Now first, let's get into the river frame of reference. That is, in our frame now, we are moving with the river. In this frame of reference, it looks like a lake. It is still water. And do we know the velocity of the boat in the still water? Yes, it's 12 meters per second in any direction in which the boat is pointed. So now let's get back to the ground frame. In the ground frame, the river is flowing with a velocity u. Point the boat in any direction you like. Draw a vector v prime of length 12 meters per second in the direction in which the boat is pointed. You have to keep the boat pointed in that direction. Add to that vectorially the velocity u of the river, and you get the velocity v in which the boat ends up moving as seen in the ground frame. If I wish to go to the point directly across, the velocity v in the ground frame should point in that direction. So I point v prime in such a direction that v prime plus u gives me v. You can see immediately that the angle, the direction in which I have to point the boat, is part of a right angle triangle, and the angle theta for it, the opposite side is 6, the hypotenuse is 12, so sine theta is half, so theta is 30 degrees. So if I keep the boat pointed at 30 degrees instead of directly across, I will end up going directly across. Just for the fun of it, we've seen what happens. Let's look at the same thing in the moving frame. But before that, note that on the opposite bank there's a black dot where the boat lands. In the river frame, the boat moves in the direction in which it is pointed. The opposite bank with the black dot moves to the left and meets the boat. So the other question is, if I keep the boat pointed straight across, where do I end up? So if I'm keeping the boat pointed straight across, draw a vector of length 12, v prime, straight across. Add to that the velocity of the river, you will get the velocity v, the direction in which the boat will end up going as seen from the ground. This time, you can see that the angle theta is given by tan theta, opposite side is 6, adjacent side is 12, tan theta is half. So theta is tan inverse half. That's the direction in which you end up going. Where do you land? Suppose the width of the river is 600 meters, and if I keep the boat pointed straight across, let's say I end up x meters downstream. In that case, you can see from similar triangles that x by 600 is the same thing as tan theta, which is half. Therefore, x is 300 meters. So if I keep the boat pointed straight across, I will end up 300 meters downstream. So now, I hope you realize that knowing the velocity of a boat in still water, I can predict in which direction it will move in any river if I point it in whatever direction I like. Or if I want to get to a particular point, I know which direction to point it in. So that's it. I'll see you in the next video. Bye-bye.